Last time we started speaking about matter construction, right? And we were speaking about the smallest part of matter. That is, what is the smallest building unit of matter? Ammar? The smallest. Yes, very good. Molecules are the smallest building unit of matter. And Tuqa, what is the smallest building unit of our body? Smallest building unit of our body. What is it? Yes, Tuqa? Okay. Who knows? We said that our body is consisting from systems, then organs, then tissues. Yes, Ammar. Cells, right? Cells. We said that we have like cells, the smallest building unit of our body, the cell. Look here. We have, this is our body that is consisting from some systems. The systems consisting from some organs, then some tissues, then cells. Good morning, Esther. How are you?
Fine, thanks.
Good morning, Abdul Karim. What are you doing? I think you didn't attend last time, Esther, Abdul Karim, and Saif, right? So I'm going to make a quick revision on the part that we took together last time, then we are going to start inshallah. Okay? Okay. We said that mainly our body is consisting, or the building unit, or the smallest unit in our body is the cell. Yes, there is something smaller that we are going to take it now. That is, we are calling it the smallest part of matter, or the smallest building unit of matter. What is it? It is the molecule. What is it? Something called molecule. What is the molecule? It is the smallest building unit of matter that can be found freely, carrying the same properties of matter. Okay? Like we said example about that, the perfume. Once you open the perfume or put or spray some of it on your body, you are going to smell it even in the place, in the same room that is away from the part that you sprayed this perfume. Why? Because the molecules that forming up or building up the perfume is moving already all over the room. Okay, carrying the same smell of this perfume. So the molecule is the smallest part of matter that can exist freely, and it can have the properties of matter. Look here, let's imagine there is some perfume in this beaker. Once I leave the perfume inside the beaker, the molecules inside this is the shape of the molecule, but we can see them with our eyes. So these are the molecules. Once we leave them inside the beaker, they are moving outside this beaker. Okay, that's why we can smell the perfume away from its place. So the odor of the perfume spreads all over the room, and the mass of the beaker decreases. All of this we took last time together. Good morning, Tuqa, Ahmed. Good morning, Mariam.
Good morning.
Good morning, dear.
Good morning.
Okay. So we said that we started speaking about the properties of molecules. So what are molecules again? Anyone can say it? What are molecules? Anyone? Any volunteer? Okay, Tuqa.
Little particles that can move freely
Mm.
and they are in continuous motion.
It's very good. They are the smallest building units of matter that can move freely, carrying the same properties of matter. It's very good. Okay. All right, we started speaking about the properties of matter. Okay, we're saying that the matter is in any state, solid or liquid or gas, they are composed of the smallest building unit that are called molecules. So what are the smallest building units? Molecules. Okay. Yes, very good. The smallest building unit are molecules. Yes, very good. Okay, let's confirm your presence, Abdul Karim.
Yes, teacher. Yes, teacher.
Yes, Abdul Karim. Did you read this part of lesson that you didn't attend? Or not yet?
No, teacher.
Okay, so if I ask you now, what is the smallest building unit of matter?
Molecules.
Yes, molecules. Very good. Okay, just focus. I'm revising now. Thank you. So the matter, any matter, what is matter? Anything we have, anything in our life is a matter. Anything that has mass and volume is matter. Okay, so what is matter? The matter is anything that has mass and volume. What is the smallest building unit of matter? For example, the pencil. Is the pencil matter? Yes, it has mass and volume, so the pencil is matter, right? Okay, so if the pencil is matter, it means what is the smallest thing that is building up this pencil? It is molecule. It is molecules, the smallest building unit of everything. Right. What are the properties? How can we describe these molecules? We have three properties we are going to take together. Molecules of matter are in continuous motion. They are moving all the time. Okay, there are intermolecular spaces among the molecules and attraction forces among the molecules as well. Inshallah, after the session, I will send the group the link of last session that you didn't attend, so you can listen to it again, inshallah.
So
Okay.
what is number two? I think number two and number
What?
three.
Yes, yes. Yes, I'm going to explain them again now. Okay, let's start with the first one. And we have Omar and Mariam. Good morning, Omar and Mariam. Okay, let's see this. Can you see this picture? There are the shapes of the molecules. They are molecules. They are in continuous motion. But we can see them because they are very small. So that's why we can see their movement. How can we prove that they are moving? So the first of all, the first property we are speaking about, molecules of matter are in a state of continuous motion. They are moving all the time. Who can remind us from who attended last time? How can we prove it? How can we prove that the molecules are in continuous motion? Okay.
And put a container with perfume and leave it. Yeah.
Okay.
Yeah.
Yes. Both of them are correct. No problem.
And leave it for a while in air, and afterward the volume is less.
Yes, that's right. Very good. Thank you. Okay, so here we have another example here. If we add just some points of ink And this example, this purple thing, this is the, it's called potassium permanganate. Potassium permanganate. It's just kind of something like the dye, okay? Just we are going to add even food coloring. We can add some of them on the water, some drops on the water. What is going to happen? What will happen? If I add the drops of ink in water, what will happen? Yes.
They smooth motion.
The water, all of the water, without mixing them, all of the water will become violet color with the same color of the potassium permanganate with this food coloring. Why? I didn't mix them. Because the molecules of the dye and the molecules of water already are in continuous motion. Because they are moving, that's why they colored all the water with the violet color. Okay, so we have here that if we added, or the violet color of the potassium permanganate is spread gradually through the water. It spreads gradually through the water. So the permanganate dissociate or dissolve in the particles of the water, so its color change. That is the proof that the molecules are in continuous motion. So the first property about molecules is safe. What is the first property about molecules? That is safe.
Molecules of matter are in continuous motion.
Yes, very good. The molecules of matter are in continuous motion. The molecules, they are very small particles that are making up this matter. Like the water is forming from molecules. This food coloring forming from molecules. Our body, we have formed of molecules. So any matter, okay? So the first one that is the molecules are in continuous motion. Okay. What is the second property? The second property, they are saying that there's something called intermolecular spaces among the molecules of matter. What does it mean? They said, okay, let's make an experiment together. First, if we imagine this is a box, okay, and this box is solid. All of us already know that the box is solid. So they are building up of molecules or particles that they close together, close to each other. But if you focus here, can you see these white spaces? They are not that tight together. There is some spaces between them. So they are called intermolecular spaces. Intermolecular, they are molecules. Inter, it means inside them, okay? So that's why we are calling them intermolecular spaces among the molecules of matter. How can we prove that we have intermolecular spaces? First of all, if we add a beaker now, okay, containing water, and I have water, for example, 3 liters, and I'm going to bring another beaker that contains 2 liters of alcohol. I'm going to mix them together. Who can tell me what should the volume I have here by mixing water and alcohol? I have 3 water and 2 alcohol. What will be the new volume if I add them together? They should be what? They should. First, if we calculate it before we know anything, it should be 5, right? Because we're going 2 plus 3. I have 2 alcohol and 3 water. If I add both of them here together, the water plus alcohol, they should be, we are predicting that they are 5. But when I measured the volume of both of them, I find it, for example, 4.5 liters. Where this 0.5 or this half liter gone? Where did it go? So, yes, the alcohol enters in the intermolecular spaces between the water. This is the water. These are the particles of the water. Where the alcohol just combines the intermolecular spaces between the water. Okay, that's why they escaped. We don't have them. This 0.5 liter entered already in the intermolecular spaces of water. That's why they are not found anymore. That's why their volumes together decreases. Okay, so this is the proof, the presence of intermolecular spaces among the molecules of matter, like we saw in this picture. Here, they are the intermolecular spaces, these blue parts. They are the intermolecular spaces. This is solid. How about liquid? The particles, they are not very close like in solid. We have some spaces. So we have more spaces between them in liquid. How about gas? Gas, no, the molecules are very far away from each other. So we have very big intermolecular spaces. Okay, so the second property about molecules is that they have spaces in between them. They have spaces in between them. So we have here the first question. Why the volume of a mixture of water and alcohol is less than the sum of them before mixing? Why they are not the sum of them? Abdul Karim? Yes, why the sum of a mixture of water and alcohol less than the volume of the mixture less than the sum of them before mixing? Why they are not 5 when I added 2 and 3?
Because the alcohol occupies the free space on the molecules of water.
Excellent, very good. Thank you. So, because some molecules of alcohol occupy or enter in the intermolecular spaces among the molecules of water. Very good. It is the same here if we think about why, when we add salt or sugar to water, they disappear. Why they disappear? Where they go? Omar? Omar, can you hear me? Mariam? Rufaida? Yes, Rufaida. We're just reading together. Where are you guys? Ahmed.
Yes.
Yes, Rufaida. How are you?
Fine.
Alhamdulillah. So here we are saying why when we add salt or sugar, why when you add the sugar to the water, they disappear when you mix them? Because what? Can you read it?
Teacher.
Yes. Yes, Rufaida. Can you hear me?
Yeah, can you repeat the question?
It's here. It's here. You can read the question and the answer for us. When we add salt or sugar to water, they disappear. Why? Can you read it? Because yes, the salt molecules or the sugar molecules spread among the intermolecular spaces of water. We said already, okay, Rufaida, that the water is consisting from molecules. And these molecules, they have spaces in between them. When we add the sugar, this sugar enters or spreads in these spaces. That's why they disappear, like they escape. Okay?
Teacher.
Yes, Rufaida.
النت قفل عليا.
Oh, yeah. So you can't hear me. Okay. So again, I was saying why when we add the sugar to the water, why when we add sugar to the water, the sugar disappear. Why? Because the sugar molecules are spread in the intermolecular spaces of the water, because the molecules of water has spaces. So when we add the sugar, they like disappear or spread in these spaces of the water molecules. Okay?
Okay.
Okay, that's great. Yes, Mariam, you raised your hand. Mariam? So what are the intermolecular spaces? They are spaces that found among the molecules of matter. They are the spaces found in between or among the molecules of matter. They are in solid less than liquid and in liquid less than gas. So where we can find the most amount of space between gas molecules, least of them between solid molecules. Okay, that's what we're saying, that the molecules of solid, they have limited vibrational motion. They can't move that much because the spaces in between them is small. That's why they have limited vibrational motion, because we said already that they are in continuous motion, but they don't have that much space, so they have limited vibrational motion. While the liquid, more free. About gas, it's completely free. They can move wherever they want to go. That's why once we put just one spray of perfume, it's spread all over the room. They have a lot of spaces in between them, and at the same time, they are in continuous motion. Okay, let's see if someone knows the answer. So if I ask you, Tuqa Ahmed, give reason, a drop of ink spreads through the water. Ahmed? Yeah.
Yes.
Yes, Tuqa. Why the drop? Why when we added a drop of violet ink, it spreads all over the water? Why? Because they are in what? Yes. Your voice is cutting.
Motion.
Yes, very good. Because they are in continuous motion. That's why they are spreading through the water. Thank you. Esther, why when you leave the perfume bottle open, you smell it all over the room?
What, teacher?
Why when you leave the perfume bottle, you smell it all over the room? If you leave it open, you will smell it all over the room.
Okay.
Yeah, I'm asking why.
Because the molecules is this motion.
Yes, in continuous motion, yes. They are moving all over. So that's why they spread and we can smell them. Yes, very good. Okay. So let's take the third property, then we'll make a competition. So focus here. There are attraction forces among the molecules of matter. Again, also attraction forces is something that pulls these molecules together. Like, can you see with me here the first picture about the solid? This is solid. We have three states of matter: solid, liquid, and gas. So if I ask you, what do you think the one that has the most attraction force among their molecules? Look at the pictures and just imagine with me and tell me, what do you think? The one that has the most attraction force, solid or liquid or gas? So, okay, Tuka is saying solid. Any other one? Anyone else? Solid. Okay, Yusuf, solid.
Solid.
Solid. So all of you are saying that solid has the most attraction force? In fact, yes. Yes. They have the most attraction force and the least intermolecular spaces. Look here, I have here less attraction force. It's intermediate, yani. Not very much, not very less. So that's what they are saying. It has less attraction force than solid, but they have more space, more intermolecular space than solid. Look at the gas. They, like we can say, they don't have attraction force between the molecules. Each one of them is flying away in its place. Each one of them play by himself. So we have here the particles or the molecules of matter. They don't have, we can say that they don't have attraction force, but they have a lot of spaces in between them. Let's see together a comparison between them. But before that, how can we prove the presence of attraction force between the molecules? Okay. If I ask you, Lamis, can you please take this water bottle and pour them in 3 different cups of water? Like I want one bottle to be in 3 cups of water. Is it easy to do or hard? Yani, I was asking if I have some water, can you divide this amount of water into 3 cups? Is it something easy to do?
Yes.
Yes, sure, right? How about if you have a piece of iron, and I'm asking you, if you are a hero, can you please break it for me with your hand? Can you? A piece of iron, can you break it?
Yes, we are heroes.
Okay, you are a hero, but you can't break it. Let's be honest, you can't break it. Why? Because the attraction force between the molecules of iron or this solid is very strong. So it will be very hard to break it. That's why we can't break it. So if you have a question here, why it is difficult to break an iron piece with your finger? Why? Because of the presence of a lot of attraction forces in between their molecules, because the iron is solid. So there is a strong attraction force among the iron molecules. That's why it is difficult to break a piece of iron. Again, why? Because the attraction force among molecules very strong in solids, like aluminium, like iron, like copper, okay? Any of the things that are solid. How about, we said that it's easy to divide the amount of water into portions. Why? Because it's liquid, so the attraction force among molecules is weak in liquids, okay? It's weak in liquid, that's why we can divide them. The attraction force is not that strong. So I can divide any liquid into portions, no problem. Okay, is it clear? Any problem with anyone here?
No.
MashaAllah, I liked this no. Okay, so what are the intermolecular force? What is intermolecular force? It is the force that bends the molecules of matter together. They make them in one place. Okay, it is the strongest N. Yusuf, it is the strongest N. Or Mariam? The strongest intermolecular force. In solid or liquid or gas, the strongest intermolecular force is. You didn't hear.
Yes.
Gas, the strongest?
Yes.
Mariam?
Solid.
Yes, I am used.
Solid. Yes, I am. Look, Yusuf, we have the intermolecular force. Excellent, Mariam, thank you. The intermolecular force is the strongest in solid, Yusuf. That's why it is hard to break a piece of iron, because it's solid and the attraction force is very strong. Did you try before to use a magnet and try to pull something with this magnet, then try to pull it away? This is the attraction force, the feeling of the attraction force. So it is the strongest and solid. It's weak in liquid, and we can say that it's not existed in gases. There's no attraction force in gas. Okay? Yes, Esther.
There's no question which I want to answer.
You wanted to answer? Okay. We have a lot of questions, don't worry. This is the comparison between solid, liquid, gas, and the three properties we took together. Solids, like we already know, they have definite shape and definite volume. Okay, that for example, if I have the pencil, if I take the pencil and I put it in the cup, it won't change. It will stay as it is. If I put it in the pencil case, I want to open it one day and I find the pencil change into eraser because they have definite shape and volume. They are not changing. Why? Why? If I ask you why solid have definite shape and volume, Abdul Karim, can you think about it? Why? All of the last years you were studying that solid have definite shape and definite volume, but why? What makes them have definite shape and definite volume? Abdul Karim, let's think together.
Because
What?
because
You can speak about two things: attraction force and the intermolecular space about solid. The attraction force is what?
the
In
attraction
solid.
is very strong. I mean,
Very good. Yes, very strong. Excellent. Okay, the attraction force is very strong in solid. How about the intermolecular spaces? They are wide or narrow? They are big or small? The intermolecular spaces in solid.
small.
Yes, very good. They are or they have narrow or very small intermolecular spaces and very strong intermolecular forces. That's why they have definite shape and volume. Very good, thank you. Okay, so that's why also they have limited vibrational motion. They can't move freely. Why? Because they have very strong intermolecular force and narrow intermolecular spaces. So the molecules are relatively fixed in position. They have limited vibrational motion. Okay, so about the spaces, they are very narrow, and forces, they are very strong. Okay, let's go to Acer. If I ask you about liquid, why liquid is different from solid? Why they have definite volume? Yes, but they don't have definite shape. The shape is changing. The shape of the water inside the bottle is different from the shape of the water in the cup. Why? Let's speak about also about the intermolecular spaces and the intermolecular forces.
معلش بس حضرتك قولي الحتة دي تاني.
Yes, I was asking you why liquids like water, why water has definite volume but indefinite shape. The shape is changing. So you are going to think about the, look here, this is the shape of the molecules of water. So tell me about the intermolecular force. Is it strong or weak? Tell me about the intermolecular spaces. They are wide or
molecular spaces is big. يعني في large يعني هو
yeah, yes, okay. Intermediate or more than the solid, okay. How about the intermolecular forces?
weak.
Yes, they are weak intermolecular forces, and that's why they don't have definite shape. Very good. They take the shape of the container, whatever it is. Okay, so they are more free to move. They are more free to move. All right. And we already know that the intermolecular space is relatively large, okay, or intermediate, and the force is weak. Look, Ahmed, what about gas? They don't have definite shape or definite volume. Why? Yes, Luca.
Teacher, what means large?
What?
Relatively اللي هو
Relatively large يعني it means intermediate يعني not very large but it's large, relatively large. Okay, Because when we take now the gas, we speak about gas, we are going to say it's a very large intermolecular spaces. You can see the difference by yourself. This is the shape of the molecules in solid. This is the shape of molecules in liquid. And here we go in gas. They have very large intermolecular spaces, and they have very weak intermolecular forces. That's why they don't have definite shape or volume. Okay? They are completely free to move. It's movement. They are completely free to move. This is the difference between solid, liquid, and gas related to the three properties of molecules we talked together. And now we understand more why solid have definite shape and definite volume, why liquid have definite volume but indefinite shape, and why gas has indefinite shape and indefinite volume. Okay. Any problem here? Do you want me to repeat any parts before I ask you? I'm giving you the chance to ask me before I ask you. Okay, great. Let's go. Let's do bamboozle. Yeah. Grade 7. Oh, right. We have only 10 minutes. Why 16 and 4. Oops. Let me tell you your group. Group 1. Group 1. Ammar, Saif, Toqa Muhammad, Aser. Okay. Group 2. Yusuf, Abdul Karim, Rufaida, Toqa Ahmed. Then we have team 3. Team 3, Lamis, Mariam, Omar. Who I didn't say his or her name? Anyone? Okay, so
what team? The team 1 or 3?
team 2, and I will make them 3 teams.
Okay.
Because you are 12, so that's good. So the first group, first team, Ammar. Ammar. Where is Ammar? Okay, so let's take Toqa Muhammad.
Ammar not here in Zoom.
Yes, maybe the internet makes him out. Yes, Toqa. What?
7.
7. They have indefinite shape and indefinite volume.
Teacher,
Yes.
Yes, Yusuf.
I'm in team what?
Yusuf, team 2. Yes. Okay, Toqa, what is the answer?
Yes.
What? Yes, I'm asking. Who are they?
Yes.
Gas. Oh, yes. You said gas. I thought you were saying yes. Okay, so gas. Can you tell me why?
Because it's completely free and it doesn't have a shape or volume.
Yes, why they don't have shape or volume? Speak about the intermolecular force.
It has very big intermolecular. It has very big intermolecular space between them, and it doesn't have strong.
Yes, excellent. Yes, the intermolecular force doesn't exist. Very good. Okay. Team 2, Yusuf.
Okay, miss.
Yes.
Number 10.
Number 10. 10, right? The space that are found among the molecules of matter. What is the name of this space? What is speaking about now? It's
solid.
No, the name of the space that found among the molecules of matter. What is this space among the molecules of matter? Enter what?
مش فاكرها يا مس.
You can ask someone in your team. You have in your team Abdelmalik, Rufaida, and Tuqa Ahmed.
مش عبد الكريم مش عبد الملك.
Abdelkarim. Sorry. Hey, I hope you are not sad from me, Abdelkarim.
Yes, عبد الكريم.
Okay, Abdelkarim. Can you answer for him?
Yeah. The space that are found among the molecules. Its name is intermolecular space.
Yes, intermolecular space. Very good.
شاطر.
Thank you. Okay. We have team 3. Okay, Mariam.
I am team what? I don't know. Team 1.
Esther, team 1, team 1. Yes, Mariam.
Number 9.
Number 9. When you leave the perfume bottle open, you smell it all over the room. Do you know why?
Yes, because the molecules of the perfume spreads to the air.
Yes, because they are in what?
Because they are in continuous motion.
Excellent, excellent, amazing, very good. Hey, well done. Ammar, you're saying that you can't hear me? Why? Ammar. Okay. To answer until Ammar hears me.
Okay. Number 12.
Number what?
13. 13, teacher.
Okay. I was just writing for Ammar. If he can, I know Allah. 1 second. Oh, okay. I was calling myself. Number 13. Okay. Okay, Esther, you have a bad decision that you have to take now. What?
Team 2.
Team 2. What? Yusuf is choosing himself, mashallah.
لا بس أنا كنت فاكرة يا مس هيزود مش هينقص.
Okay, no problem. So team 2 now, Rufaida.
Yes.
Yes, Rufaida. What is the number? Quickly.
8.
8. Matter consists of a small building units called. What is the smallest building unit of matter?
Cell.
The smallest building unit of our body is cell. Very good. How about the smallest building unit of matter that we took today? Starts with M. Ma. And that we said that any matter that is consisting. Yes, molecules. Excellent. Very good. Molecules. And Lamis.
صح بقينا 5.
Alhamdulillah. Lamis, can you hear me? Ammar, can you hear me now?
it's 10 تمام 5 تمام.
Lamis. Okay. Omar. Lamis, Omar, can you hear me? Hey. Omar. Choose a number. Yes, dear. Choose a number.
1.
Number 1. In which state are the particles of matter unorganized, moving very quickly, or they have large intermolecular spaces?
Large.
Hmm.
Solid.
Solid, they are moving very quickly, or they have limited motion in solid? You have solid, liquid, and gas. Which one moves very quickly and freely? Again. Yes, Omar. The one that has speed motion, large intermolecular spaces, once you spread it, solid or liquid or gas?
Liquid.
Liquid. So, make it check. Anyone of team 3 agree with this answer? Because let's think about it. The one that moves very quickly, the one that has the more intermolecular spaces. If we try to draw the molecules together, I will find that the solid, they are the shape of the molecules. This is the liquid, and this is the gas. The one that can move, the most one that can move freely is
Gas.
Gas. Very good. Can make it correct. It's the first time. Ammar still don't hear me, huh? I can only see. Okay. Your turn. Choose a number.
Really, Miss.
Ammar. Okay, you didn't answer it, huh? Or you did? You choose 6. The properties of molecules of matter. Yeah, you can say any one of the 3 that we took together. You can open the mic. Can't hear me. Okay, he said already in continuous motion. Okay, very good. That the molecules of matter are in continuous motion. Abdel Karim, team 2.
Yes.
Quickly.
Number 12.
12. Give reason a drop of ink spreads through the water. What property you are going to speak about here? About molecules?
I think
Okay. Why do you think?
continuous
Motion, movement. You can say it movement. It is the same meaning. If you understand it, that without mixing, once we add the drops of ink, it spreads because they are moving continuously. Okay? Yes, very good. Excellent. Because they are in continuous motion. And team 3. Lamis, you can hear me. So Mariam again. Mariam.
Number 2.
Wow. Great. Okay.
بس احنا ليه ما بنزودش؟ ليه ما بنزودش؟
Steve. What is Steve? Steve?
Number 3.
3. What is the smallest part of matter? It's a gifted question as well. What is the smallest part of matter?
Molecules.
Molecules. Yes. Very good. And Tuqa Ahmed, team 2. Yeah, Toka. Toka, the session finished quickly. Can you hear me?
Miss, I want to answer. خلينا نفوز.
Choose any number and yes, finally.
Number
Toka, choose a
4.
number.
Number 4.
Toka, it's her turn. Okay, I'll make it number 4 because I can't hear you.
Team 1.
Okay.
Team 1.
Team 1.
شفت بقى عشان تعملها تاني فينا.
Okay, bad revenge. Okay.
Yes.
Toka, I think you hear me late, I think. Okay, Omar, quickly. Team 3.
Yes.
Which number?
5.
5. Again, the smallest building unit of our body.
Cell.
Well, excellent. Very good. And team 1, Toka Muhammad again. Any one of you didn't answer at all? Which number?
14.
When we add salt or sugar to water, they disappear. Quickly.
Because there are intermolecular spaces in water.
Very good. And team 2, Rufaida. Toka Ahmed. Toka Ahmed, if you can hear me. Yes. 15.
Number
You are
5.
playing.
Team 2.
Team 1 يا مس.
Team 3.
I'm sorry. No,
Miss.
Rufaida.
1 miss.
Okay,
Team 2
one
اللي
second.
يختاروا. Team 1. Team 1.
Yusuf, wait a second. Yes, Toka or Rufaida?
3.
تمام ده اختيار ذكي.
ليه هم خسرونا خليهم خسرهم.
Okay. Stop now. Team 3, Mariam or anyone. Characterized by relatively large intermolecular spaces and weak forces.
Relatively large. Teacher.
Yeah, intermolecular spaces. Very, very. Okay, let's make it relatively large. Intermediate intermolecular spaces. Team 3.
هو السؤال ده جه 3 مرات.
No, this one is not the same. Relatively large intermolecular spaces and weak intermolecular forces.
Liquid.
Solid or liquid or gas. Very good, Mariam. Liquid. Excellent.
Team 3 is the winner. And
كنت بقول لكم اعملوا تيم
Okay. Guys, the session finished. I hope you studied the lesson. Next time, inshallah, we'll make another competition. See who will win.
يا مس ممكن اسال حضرتك سؤال؟ بص
Quickly.
حضرتك البرنامج اللي حضرتك بتاع اللي هو بتاع الأسئلة ده حضرتك جايباه منين؟
Bamboozle. But I am making it. You won't find the questions ready. Okay, see you inshallah next time. Goodbye.
goodbye.
Good morning.